Hi, welcome back. In the last video log, what I did was I checked some of the power supply line on the schematic, ticking off as we went along, checking that the input voltages were correct, the output voltages, all voltages were as expected, and everything seemed to check out okay. And what I did since then is I went a bit further with the cleaning process. You may just be able to notice that it is a lot cleaner. This thing was filthy. Fortunately, the only problem was dust. We're not always that lucky. This one was just dust. And what I did is, using a fairly soft, very soft brush, I just brushed at it slowly, carefully. You can't lose patience with this. You've got to be very, very careful. And the reason is pretty obvious. When you look a bit closer here, this is one of those that has these little hair wires coming off the coils straight out in the open. Now, a brush can damage that pretty badly. And that's not what you want to do. Those are the kind of solder connections you do not want to have to redo if you can avoid it. And that's exactly what I did. I avoided it. So it's cleaner on the underside. Everything was brushed away and vacuumed away. Obviously, as we go along, little bits and pieces get cleaned a lot better. Cleaning on the top end was done with the same procedure as the bottom to start off with, brushing away the dust. And then cotton swabs with just dipped in warm water and a little bit of wash-up liquid. You've got to be very careful that water doesn't pour in, and I only use the water to get the surface dirt off. And then I dry it up, clean it up with the cotton swabs. And what I like to do then is I like to brush it over with some WD-40 to create a protective coating and a little bit of a shine to it, as you can see. The transformer section has been cleaned up. The rest is still a challenge. Right, this is what we've got so far. The last time I removed this cap here, this safety cap, and there it is there. When I measured it, I got 13 nanofarads. It's supposed to be 5. I then replaced it with a 4.7, and it's also measuring quite a bit of leakage, even at as low as 150 volts. So that was a good move. Then we checked this line, and if you recall, I decided to leave in the 50 microfarad filter cap for now, although I did detect that it was leaking at the top, but it seems to be doing a fairly good job in that there's very little hum, audible hum. We did measure 5.3 volt AC ripple on there, and that would be at 100 Hertz because of the bridge rectifier. Then that line came across here and up to one of the output transformer's primaries. We also saw a cap across the output transformer primary, and that was replaced as well. That's this guy. Again, it's supposed to be 5 nanofarads. I measured 20 nanofarads. I haven't even measured this one for leakage yet, but I can imagine it will be fairly similar to the other one. This goes to the plate of the EL84 power tube, and that's been checked. I knew that this connection was working originally because when we started it up we got some sound, but what this capacitor was doing was actually shorting a lot of high frequencies to ground effectively. So the removal of that one and replacing it with a polypropylene 4.7 nanofarad cap will obviously improve the high frequency response of this thing. Now the next stage, what I want to do is I want to check the power amplifier completely. So I'll be following this part of the circuit here, checking the voltages coming through there. We'll follow the lines later, checking the values of all components in this vicinity, just to ensure that what we have is in accordance with the schematic or not far off. Now, I expect a little bit of deviation on the resistors. After all, this thing is, what is it, 63 years old? It's respectable. You need to treat it with a lot of care, and you have to expect a few values to have drifted in the meantime. The capacitors obviously will mostly be leaky or off spec, but the resistors tend to be okay for a while. So I'll do the checking on all of them, and we'll follow along as we go. What I want to do is I want to get this section. Here we have the EL84, and it's cathode biased, so we've got a 140 ohm resistor here which sets the bias point. There's a cathode bypass cap of 50 microfarad which helps the bass response of the EL84 and also increases its gain. If we follow this line, we had the B plus coming in here, having previously been filtered slightly by that cap over there. So B plus comes in here. It goes through part of the transformer, which in this case acts as a choke to reduce the ripple further. As we go back in the circuit to the preamp stage, we want as little ripple as possible. We then have a resistor coming to here to this point. This point goes off here through the switching to the EM80 Magic Eye tube. A ripple there we're not too worried about. That's just an indicator. What is important is when we're here, we go through, there will be another cap here somewhere, because this comes from there through the this inductance section, so this choke. There is a resistor, and usually you'll find a capacitor somewhere. It's not there. If we follow through, and there it is. There is the second 50 microfarad capacitor that's part of the can that we looked at that includes that one. So that creates a second level of filtering. And that filtered B plus then goes through a 2K resistor to another electrolytic, which is another filter stage. So we're basically getting low pass filters here to cut off the hum as much as possible. Then that is a slightly lower voltage to the one that came in. There's a voltage drop through there. There's a voltage drop through there. And what we'll have here is a few volts lower than the one coming in. And that feeds the screen grid of the EL84 power amp stage. It then also branches off that way through a 200K resistor to the plate of this tube here, this this triode here. That'll be a preamp. So what I want to do is follow this, check out this whole stage. Make sure that this stage is working properly, because what we're doing as we go back is improving the quality of the sound. These EL84 tubes can produce some really, really nice sound. It all depends on the type of transformer here, the frequency response and the capacity of the transformer, and then obviously on the speaker. The speaker I'm not too optimistic about, but it'll do. However, if we can get this section working perfectly and cleanly, we're working back towards the preamp, which will then allow us to test the entire audio stage. And what we will have there, if we choose the phono input on the piano buttons on the front, is really an audio power amplifier. Mono, but audio power amplifier with its preamp stage and a power tube on the output driving the speaker in a single-ended configuration. It's only one tube driving the output transformer. So I'm going to go through these components and come back, and we'll then see what we found in terms of values. Right, let's see if we can test some values here. The radio is off, obviously, and I've got the multimeter in resistance measuring pin 3 of the output tube. Now pin 3 is the cathode, and there's a 140 ohm resistor to ground, this guy over here. So let me just touch the chassis, which is ground. and we get 138 ohms. Damn, that's close. This thing is right on spec, 138 ohms. That one's fine. If we go to pin 2, pin 2 is the grid. There's a 1K resistor coming in there, 1022, right on spec. This thing is unbelievably close in value. So that one's perfect as well. The capacitor in parallel with this one, the cathode cap, this one to ground, I'll be replacing. It's an electrolytic, 50 microfarads. I'll put in it's a low voltage because the cathode voltage of this thing will be a few volts, nothing high, but so they've got a 15 volt, 50 microfarad, 15 volt electrolytic to ground. I'll be replacing that one as well. But I'm checking the resistors for now. So those two resistors are spot on. If we look at this 1K that we've just measured, we then have this capacitor here, which it's the coupling capacitor for the audio coming in. That I'll be replacing as well. But from the same point, there is a 1 meg to ground, and we've got 900 and it's climbing up, it's charging something, but 980 ohms and climbing. So we're spot on there as well. The screen is this one over here. It's pin 9. Pin 9 goes to here, and pin 9 has a 2K somewhere along here. Where is it? There'll be a 2K resistor here. There we go. There's a 2K resistor, 1992 ohms. Damn, spot on. This one's fine as well. Now, from there, we're back to where the B plus goes through the choke. And so 2K, we then should find a 1K resistor leading off to the transformer. And there it is. Can you get any closer than that? Maybe, but not on a 60-year-old component. 1K, spot on. So, the only components we haven't checked in this section are the capacitors. The second and third filtering cap, as well as the cathode bypass capacitor, that one there. So I'm going to be replacing the capacitors and then get back to you and show you what we've done so far. Right, some capacitors changed, and here we have them. That 10 nanofarad coupling cap was changed to a 10 nanofarad 600 volt. This is an orange drop, probably not the best, or probably too good to be put in here, but you use what you have. I've run out of 10 nanofarads. That's been put in there. The one I took out of there actually read 38 nanofarad. It's in pretty poor shape. It just basically broke apart. So that's been replaced. The electrolytic cathode bypass cap I replaced as well with that one there. Actually a very good quality cap for this function. I've put in 100 microfarad because it actually improves the sound. All it does is it will actually allow lower frequencies to go through a bit better. So that's been replaced. And what I measured on this one was 71 microfarads, from 50 to 71. So it's drifted off as well. The other cap that I checked was this one here. This one is a cap that comes to the same point as the coupling cap, as this one. And then they then go off through this 1K to the grid. What this is a feedback loop that includes the tone control. These caps very rarely go off, and true to form, I removed this connection here to measure it out of circuit, and I got 2.516 nanofarad. It's supposed to be a 2.5 nanofarad. So it is spot on, no question. So what we have so far is the entire power amp section around the EL84 tube over there, checked, rectified, corrected, replaced, and hopefully in better working order than it was before. The connection coming through to this cap, the one that's in the feedback loop, is actually from the treble control, and the pot that I'll show you on the circuit in a minute reads 13 meg as opposed to 6 meg in the schematic. Now, I find it strange that it's drifted that far, but anything's possible. It's an open back potentiometer. I'll show you in a minute. It is this guy over here. It's open backed, so it's been open to the elements all this time, and it could well have drifted as much as that. Now, if we go look at the schematic to the changes or the work we've done, so we have all this in blue checked. Here's the bypass cap that I replaced. It was 71 microfarads, replaced it for 100. Now, this 71, it wouldn't be detrimental to the sound, but it could well be leaking as well, and I replaced them anyway. This one here came out as 20 nanofarad. This is the one that was across the output transformer, as we saw earlier. Here's that feedback path coming from the transformer. It's a winding in the output transformer. I have to check where this goes. I haven't checked its destination. It's probably, we'll check, probably a speaker, but it comes through the winding, goes to that pot over there, which is supposed to be 6 meg. It's reading 12 point something meg, but it is logarithmic, which means that the lower half does most of the adjustments in the low value range. So it may well, we'll get away with it, or if not, we can always replace that, but I wouldn't want to. I don't know where to find a pot like that. And it may well have been used, a different value may well have been used in this radio anyway. This is the one that I checked out, absolutely correct, the polypropylene one, I believe that. No, not the poly one, it's that polyester one. Slap bang on. That is the coupling cap, the 10 nanofarad, which I replaced. It was a 38. So now we've got audio coming in here from the preamp, coming in here, getting mixed with the feedback, with a varying degree of feedback, because you can adjust the pot here. This is just set up as a variable resistor. It goes through the 2.5 nanofarad, so it's decoupled as well. The signal, the joint signal, then goes through to the grid resistor. It's a 1 meg, but there's I beg your pardon, the resistor to ground serving as reference, and the 1K grid resistor, which we've checked. These are the ones that are really, really close to the original values. So all this has been checked, and it checks out fine. Obviously with the exception of the caps, but they've been replaced, and hopefully this is as good as new, if not better. Right, and here we have it. Powered it up again. Put it on FM. And we've got sound again, and it's a lot better than before. Much, much better. We'll then follow up next with the preamp stage. All right, that's it for now. See you soon.